The next one we're going to do, we just did 8, number 9. So I'm going to write it down. So I'll write it down so we can look at it together. We're going to go x minus 2y minus 5y x squared. Sorry. X squared. Oh, sorry. I'm writing down the question wrong. The question itself is just x squared. That's my fault. So x squared plus 10xy. Okay, so that's this one here. X minus 2y minus 5x squared plus 10xy. X minus 2y minus 5x squared plus 10xy. So there's 4 terms. So look at them with me. It's 1, 2, 3, 4 terms. This, the only way we know right now, is a 2 by 2 factoring. So we look and say, is there something common between those two? X and 2y? I don't see anything. How about these two? There's a 5 and an x in those. Will that help me with the x and the 2? Maybe, maybe. So I'm going to try this. So we're going to leave this alone. If I put it in a bracket, it's not hurting anyone because there's nothing around it. I'll just bracket that. Here I'm going to take out the minus, and 5 goes into both of them, so common factor, and there's an x I can take from both of them. So to be fair, I'm going to take out 1x from both of them and the 5 from both of them. And you're left with an x here, one more x is left, and 2y. Uh-oh, and that is minus, actually, because, oops, I'm out of paper. Because when I divide by the negative, it is a minus. Sorry, just trying to find something I can erase that with. Nope, I can't. So let's take that one away, and we're going to make that a minus. Sorry, I can't find anything to erase with. This guy's out. All right, so then we've got these two brackets are the same. Sorry, that's distracting. X minus 2y minus 5x, x minus 2y. So that makes them the common factor, like that. You're going to write down the common factor once. You're saying it's common for both of the terms, but you're writing it only once. Then you're going to write down what's left over. So again, picture that you're plucking it out, that you're actually physically moving this beautiful thing out, this beautiful little term right here, right? So we're grabbing it, and we're saying that these two are the same. So I'm just going to highlight. So this whole thing and this whole thing are the same, and I grabbed it and took it out. But that means I physically took that factor out and put it to the side, and I'm saying I've got 1 for both of the terms inside, so only write it once. What you write left over is, if I took this one out, there's nothing left. But it doesn't mean it was 0. There's actually an invisible 1 in front, so let's leave a 1 there. Okay? Then if I grab this one out as well, I have left a minus 5x there. And then that is it. That's it. Right, so I took out the common one, so these green ones, I picked them up, put them outside, just put 1 to represent the fact that there was 1 for each of the 2 terms in there. All right, then when I look at the next question, number 10, it's x to the 4 minus 1. So as soon as I see 2 terms with a minus in between, I think to myself, maybe this is the difference, which means minus, right? Minus of squares. Could it be? And yes, is this a perfect square? So this one is actually x squared times x squared. So yes, it's a perfect square. X squared times x squared is a perfect square to the 4. This is a perfect square because it's 1 times 1. So it's minus 1 plus 1. Isn't that beautifully done? Then you have to look at your answer and go, wait, isn't that a difference of squares? So yes, it is. So that we're going to do again right here. That is actually x minus 1, x plus 1 again. The same, one of each. And this guy is not a difference of squares because it's a plus in between, not a difference of squares. So I have to stop here, but keep going with this. Doesn't have to be underlined, but this is your final answer. Okay, so number 11. Okay, we're going to do number 11 together. One more time, we're going to take a look at the types. This has got 1 term, 2 term, 3 terms, so it looks like a trinomial. That's an x squared, y squared. That's an xy in the middle, so it's half of it in the middle, which is perfect. Right? So this to me looks like a simple type trinomial with a 1 coefficient. 12, I have m, 3x minus 2 minus 3x minus 2. Those two are the same. So let's write those down. So I'm going to do 11 first. So it's x squared. I'm analyzing the types as I'm doing this because you need to know when you look at it what type of question it is. So this, again, since it's a 1 in front, it's actually a simple type. It looks longer, but the first term is xy and xy. So xy times xy gets me x squared, y squared, 2 of each. It meets in the middle with half. So all we have to do is find out 2 numbers that multiply to 72. And you can do this if you want. Multiplies to 72, but adds to 21. So I have 1, 72, oh no, 2, 36, 3, 24, oh, 324, I already see it. So I'm not going to go any further. I could try 4, right? So 4 would work as well, but let's see if 324 works. That would work if I got negative 24 and a positive 3. So that would be xy, which is 1, and this would be 24 and 3. And we don't have to write it there because it's just the 24 and 3. There's nothing else happening. Now, what we want is the 24 to be negative and the 3 to be positive. Does that check with my sign here? Positive, negative, or negative, positive? It does. So we got positive, negative. Okay, number 12. Number 12 is written like this on the page. So once again, when you see the same factor, that's a common factor. When you see that, then you want to take that common factor out. So it's like you're plucking it. So I'm just like, oh, both of you have that. We're putting 1 on the side to represent the 2. Okay, this 3x minus 2 is here on the side now. And then you have to leave what's left over here. So if I pluck this one out, I'm left with an m. If I take this one out, I'm left with a, not 0, but 1. Imagine an invisible 1 there. Okay, I'm going to stop this part of the video now, and then we'll come back and do more.